Solve for the missing side, it says. In this triangle, notice what we don't have. It is a 90-degree triangle. It is a right triangle, but all we're given is the hypotenuse. It's 9 units long, right? We're not given the 2 legs, so how can we possibly, if we're not given 2 out of the 3, A, B, and C, how can we possibly solve for the missing side? Well, you have to remember something about a 45, 90, 45 triangle, or most people call it a 45, 45, 90 triangle. How do I know the other angle is 45, by the way? How do I know this angle is 45? Because the angles in a triangle add up to 180. So if you have a 45-degree angle and a 90-degree angle, the other angle has to be 45. Then you realize if these 2 angles are the same, you may remember from geometry, if you took geometry in high school, if these 2 angles are the same, then these 2 sides are the same length. In other words, it's an isosceles triangle. That's a cool name. I think you should name your firstborn Isosceles. Maybe a dog. Save it for a dog name, maybe not a human name. Isosceles, come here. Short for ISO for short. Come on, ISO. That sounds kind of cool. No, okay, never mind. It's an isosceles triangle. 2 sides are the same length, right? So that means that A equals B or B equals A. And that's the key to solving this problem. So now, if instead of saying A squared plus B squared equals C squared, we could say A squared plus A squared equals C squared, which is 9 squared. C is 9. Because A and B are equal. Does everybody see that? On the left side, if I have 1A squared is 1A squared, plus 1A squared, how many A squareds do I have? 2A squared. And then what's 9 squared? 81. So now, I don't know if you noticed this, but in every single one of these problems, you're going to, if necessary, you're going to solve for the variable or the unknown that's being squared, right? You're going to get that by itself. If I haven't made that clear enough yet, please let that sink in right now. Get the unknown that's being squared by itself, and then you can just take the square root of both sides. That's the trick. So how do I get 2A squared by itself? I'm multiplying by 2, so what do I have to do? To get rid of that 2, divide. Divide it. So I get 81 over 2 on the right side. A squared equals 81 halves. So what do you do at this point? Square root both sides. And make sure you say the right thing. Don't say square both sides, because that means something completely different, right? That's the opposite of what you mean if you say square both sides. We're taking the square root of both sides. Okay, so then what do we get? We get just A on the left side equals square root of 81 over 2. Yeah, it's because the square root breaks up over division. You get the square root of 81 over the square root of 2. But what's the square root of 81? 9, so you get 9 over root 2. What would you do if you were asked to get rid of the radical in the denominator? What would you do? Yeah. If you were asked to rationalize the denominator, you would multiply numerator and denominator by radical 2. But I'm not going to go there because I don't really care about that in this problem. This time, we have another special triangle. We have another special triangle. It has a 90-degree angle, a 60-degree angle. What's the other angle have to be? 30. In order for them to add up to be one, if you didn't know, you could just take 180 minus the 90-degree angle, 180 degrees minus 90 degrees minus 60 degrees. What's left over? 30 degrees. 30 degrees. So I'm going to give you that this length here is 2. The length of the shortest side is 2. All right, so I'm going to show you a trick for getting the other 2 sides based on the fact that it's a 30, 60, 90 triangle. That's one of our special triangles. And this is a weird trick, but the formula we end up with is pretty cool and pretty useful. Can you imagine taking a copy of this triangle and flipping it? Hey, you don't have to imagine it. I can do it. Let me take a copy of this triangle, and I'm going to reflect it along this long vertical side here. Now, what I want to do with this is I want to take the mirror image of it. I want to reflect it kind of across the vertical side. So does everybody see what I did? I just kind of, if this were on a piece of paper, I took the piece of paper and flipped it over, right? That's what I did. So now, let me change the colors so that we can recognize what it is. And I'm going to put this new version right next to it. Now I want you to remember what this angle was. This angle, what it still is 30 degrees. Because we just kind of flipped this and then got that angle, right? This angle goes over to here, right? When you flip it, so that angle is 60 degrees. And so what kind of triangle have we created if you look at the big triangle?
A right triangle.
No, it's not a right triangle anymore. In fact, if you erase this guy in the middle here, I didn't mean to erase that bottom side. If you erase that guy in the middle there, then isn't that a 60-60-60 triangle, an equilateral triangle? Does everybody see that? When you erase that vertical side, you get a big triangle that's an equilateral triangle, so all the sides are the same length. But not only that, if you know that this bottom side is length 2, then what did you just discover? Okay, you know this side is 2. What did you just discover about the entire length of a side? It's 4, which means this side is 4. This side is 4. Everybody see that? So you used a mirror image trick, not even any algebra, to get the length of one of the sides. That's kind of cool if you think about it. And then now you've got 2 of the sides. What trick could you use to get the third side? Pythagorean theorem. So a squared plus b squared equals c squared. You could call, if you wanted to, you could call 2 b or a. I'll call it a. But this guy has got to be called c because that's the hypotenuse, right? So fill it in. What do we get?
A squared equals 12.
So we fill in 2 for a. We get 2 squared plus b is what's missing. B squared is equal to 4 squared, right?
Yeah.
But you're right. You get 4 there plus b squared is equal to 16. If you square the 4 and subtract the 4, you get b squared is equal to 12, just like you said. Pretty quick thinking there. So what does b equal? If you take the square root of both sides, you get the square root of 12, right? But 12 is 4 times 3, so how could you break it down? 2 root 3. So b is 2 root 3, and c was 4. So that solves the problem. These were the missing sides, right? But if we had just left this as a, we would have discovered a formula for any 30, 60, 90 triangle. So let me tell you what that formula is. So if you just have any 30, 60, 90 triangle, in other words, one of the angles is 30, one of them's 60, one of them's 90, then this formula will work every time. Let's say you leave this side as length a. Then always the hypotenuse is twice a, right? I mean, that's kind of what we discovered with that mirror image trick. But even better yet, if you just replaced this in this little derivation we got here, if you just leave 2 as a, you would see, or replace it with 1, you would see that you just multiply whatever was there to begin with by radical 3 to get the other leg. So it's, in general, it's a radical 3. So if you know, in a 30, 60, 90 triangle, if you know the shortest side is length a, the longest side is twice a, and the other leg is a times root 3. And that works every single time.